All right, Civil 7, you should have already watched one brief video introducing topo maps, what they're generally used for, how they have contour lines to show elevation, but we want to go a little bit deeper here for just 1 sec before you go into the next video and make sure we understand a few key features from our topo maps and that you really understand how a contour line shows an elevation. So here I have a very fancy topo, and we're not going to say that each contour line is 40 feet or 100 feet. We're going to say it's 1 inch. So we have 1, 2, 3, 4 shown all the way up to 7 inches in height. And literally we're going to say that the space between each of our contour lines is equivalent to 1 inch in vertical height. So let's see what that looks like. So if I were to take this and turn it, I'm going to say the space between my bottom line and my next line up, which in most cases is pretty darn vertical, we don't really see the change, that's going to be 1 inch. But let's take this and we're going to start adding additional layers to our shape. So if we wanted to bring in and now go from the topo that we can see, and let's give it another inch of height. And then we can bring in another inch of height, and we can keep adding these layers, and all of our layers are coming into us 1 inch thick, and we can still see our contour lines growing. But as I still see my smaller contours lines here telling me I still have inches of height to add, I can see the lower contour lines still representing that I'm coming up at a set height until finally we can put on all of our layers and show our full shape, our 7 inch tall shape. But as we look at it from above, and we're just looking at its contour lines, we can turn it, and suddenly we have our three-dimensional model, which is what the topograph is really trying to show you, is a 3D representation, so that not only do you get horizontal distance, but you get vertical distance as well by understanding that each horizontal line is at the same elevation all the way around that horizontal line. The horizontal lines, or the contour lines, are connecting points of equal elevation. All right, so there's some key things that we can see on our topo, and we just want to point out what some of these key features are. So if you have concentric circles, they don't have to be perfect circles, but if you're getting contour lines that are coming together and getting closer and closer together, these are basically representing a peak or high point, whatever you want to refer to that as, but it's a peak or a summit, right? That's going to be your highest point of elevation. Now conversely, we could have something that looks very similar, but instead of just being circles, there's now these additional tick marks that have been added. And when we add in the tick marks, what we're actually indicating is that this is a depression. So you could think of a crater, you could think of a sinkhole, but that's what we're representing when we start adding tick marks. So definitely the lowest spot in the US there in Death Valley is going to have some tick marks because it's below sea level. Now additionally, you might see some contour lines that end up sort of creating little peaked V's. We can see some. We have some peaked V's here, but we also have almost V shapes. They don't have to be perfect V's, they can be rounded. And you'd have water flowing sometimes through those. So let's darken up that water. And I'm putting an arrow because I'm pointing the direction, in this case, the water would be flowing down. And so valleys, this is a valley with a stream. And it's important to note that the V, if you will, points uphill. And then finally, we see other sort of V shapes along our topo. And I can have the same sort of V. It doesn't have to be a hard V. It could be sort of a U shape. And this is pointing out a ridge, and on a ridge, your V points downhill. Now, sometimes we get lucky and we actually have contour indicators that tell us which way, what uphill and downhill is, because if I'm at 1, 2, or 3, I'm at a lower elevation. I'm going to be at 7 inches tall, or 6 inches tall, or 1,000 feet, 2,000 feet. And so sometimes we can tell what's uphill or downhill. We have our water here in this region, and we would know that the water would be flowing, in this case, upwards, because that would be our downhill direction, because the V's point uphill, water always flows downhill. But if we don't have the elevation numbers, we can just look at the direction of the V to see. Now, when we want to look at what a ridge is and just make sure we understand, a ridge is basically a prominent piece of rock that's descending, or a prominent feature. It doesn't have to be rock, it can have earth on it. So all of these here would be considered ridges. And when we look at them in plan view or from above, we can see here we have our V, and our pointy part of our V is pointing downhill. Where we see the water, which would be considered a valley, it's a low spot between two high points. But when we look, we can see that our V's would be pointing uphill in this case, and our water is going to flow opposite of that. So when you look at it from plan view, the V's are pointing in upward direction, and that's uphill. All right, so those are some of the key features that you might see on a topographic map. You have another video to watch to help you read it a little bit closer and to actually do a little quiz, but I wanted to make sure you knew what a depression was, how to pick out a high point, how to tell the difference between a valley and a ridge. Thanks for watching.